Hello, everyone. Thank you so much for tuning in. Today, we had a sit down conversation with one of our professors and one of TU Delft's lead researchers, Professor Alderliesten.
Professor Alderliesten has almost 30 years in the aerospace industry, and today we talk about his contributions, the industry in general, and the future of aerospace. Professor Alderliesten worked on glare, a material that's present on the Airbus A380, the biggest passenger jet in the world.
If you like this podcast and you want to see more aerospace related content, please be sure to check out aerovia.org.
Enjoy.
So we're actually really curious, given that we're young university students, we wanted to know where you started out. How did you know aerospace was for you? Did you know? What made you decide?
I sort of grew in slowly um, because, as a young kid, you start looking at birds and I wish I could do that. I'm a bit reflective and philosophical as a mindset. So at some point you look at the birds and you wonder, how would I perceive the world differently than I do now if I could approach it from the way they do it? And when I grew up, at some point, I really want to do this myself. So I applied for the Air Force as a fighter pilot.
Oh, really?
Yeah. Of course, you go through the test, and at some point they tell you, sorry, you don't meet our criteria. And then they told me you can reapply in 2 years. So I went home and went for Plan B, which was at that time aerospace engineering.
You were 17.
Yeah, 17. So I was last year high school. So I applied for aerospace engineering, but because there was a numerous fixes, I had to give a second study as the Plan C. So I did maritime engineering. And then, I think the year I started was the first year that we didn't meet the 250 applications. So essentially there were even less than 250 applying to the study. So I was enrolled to the aerospace engineering. And then I still had in my mind, 2 years from now, I can apply again for fighter pilot. But when I was 2 years into the study, I was like, wait a minute. Of course, I can fly the machine. It's much more fun to design the machine. So I sort of figured I'm not going there anymore. I'll stay here and I'll finish this part.
And at the time, what planes did the Air Force have? What did you want to fly?
F-16.
F-16,
Yeah.
Classic,
Yeah.
Of course. And then you said it's gradual, your interest in aerospace, but then with specifically structures and materials, was it the same?
Yeah. So you start to, get an idea about conceptual design of an aircraft. But there was one professor at Aerospace Materials and Structures, Bout Vogelzang, who was very energetic, enthusiastic, and inspirational. And that really sort of triggered it for me. And then at some point you need to choose in which direction will I go. And then I realized that there's quite some physics and math in what we do in aerospace. And what I particularly liked about structures and materials is there's a major part which is less mathematical. It's more soft. There's some sort of implicit reasoning and it's compromising. And so where in aerospace generally is compromise between disciplines, in aerospace materials and structures, we have that ourselves as well as a compromise between the materials, the structurals, and the manufacturing part. And that really did it for me, because that felt to me that there was room for creativity.
When you were a student here at the faculty 25 years ago, or
Yeah.
almost
Oh, yeah.
30 years ago,
Yeah.
what was the profile of the aerospace students? So now you see that there's a really big, there's two main groups. Like there's people who are really fond of planes and a lot of the sustainability aspect. I want to work on the Neo. I want to work on the Flying V. There's other people who, I want to work on space flight, SpaceX and EASA, and then some people Formula One, some people wind tunnels. Was it the same when you were a student? Then there was like a noticeable divide.
Not really. Not at least not that I recall. We had the joke that almost every fellow student in the course, at least like me, had applied for the Air Force, and that aerospace engineering was Plan B essentially. But I think the reason why people opted for the study or for the direction to continue was sort of. You have to recall that in those days we still had Fokker aircraft as an aircraft manufacturer. So some people had in mind that that may be their future as well. But halfway the study, they went bankrupt, and that sort of started. Yeah, the university or the faculty had to recalibrate, but we as students also. It's like, okay, if we can't work there, then where do you work? And that opened up essentially the horizon. where people realized I don't need to stay in the Netherlands. I can go to Airbus or anywhere else in Europe, or even outside Europe for that matter. But yeah, it's at least the way I recall it, it was we are still in a sort of status quo initially, and on the flow, yeah, the environment around you changes, and you change along with it.
Right. And so were there any maybe aha moments where you're like, okay, it's got to be this, or I can't do that, given that there was so much change around you?
For me, the aha moment was more in that what you initially, well, based on the education you had, you think of, I will do it like this, or you have a certain perception of how aerospace business looks like. For me, the aha moment was where I realized if you look at the industrial practice, there's a lot of politics going on. And at some point you start to realize if I want to really, as an engineer, want to have impact, I should not only do the math right or come with a good technology or good idea, I have to bring it beyond the point that even the political side of this business start to realize we want to do that.
All right. And you talk about this political aspect. Going back to Glare, like
Yeah.
start of your career, basically streamlined project, like from idea to application in what, like 20 years. Why do you think Glare was so successful in that sense of?
It was successful for one, and that relates to people. So that professor I was referring to about Vogelzang, he was really that enthusiastic that he went out and started pushing, we have to do this. So he first tried to get it into Boeing, and then at some point it was Airbus, although in those days it was not yet called Airbus, but on the Airbus side, there was another person, an expert, who recognized the benefit of the technology, and he was the pull. So you had a proper or a perfect combination between push and pull. And then the entire environment with funding in the Netherlands and the right parties like Fokker Aerostructures being able to manufacture, and you had Airbus, NLR, and TU Delft. So the environment was there. There was at that time funding for it, and a lot of people who said, I want to do this. And in the end, Airbus was sort of bringing in the mindset, we have to certify the technology at some point. So we sort of mapped through work packages, on the properties, on the methods, on the maintenance, and all the aspects that need to be addressed. Where Airbus was sort of feeding us with we need this, we need that, and we need such. Where on the do side, we were sort of thinking of, and how can we provide that? And what I enjoyed there most is if you carefully listen to someone expressing a problem, you hear them ask for a solution. And if you look at what they ask, it's like they may interpret their problem slightly wrong or off. I can think of a better solution than he's asking me for if I address more or less the root problem. So, and that is for me always been the trigger of carefully listen to what do they express as a problem. Can I interpret that in a more fundamental way?
Right. And so now that you've touched on politics and also innovation, there's a saying, I'm not sure if you've heard of it, especially now with China, America innovates, Europe regulates. I'm just curious what your take on that is. What do you think? Do you think it's a good thing? Or
I'm not sure what I agree per se with the expression, because my experience with the US is that, the rules go farther than here in Europe.
Like regulation?
In regulation. So they also have, for example, that ITR, the restrictions on, what we had, for example, at some day that, we developed the FML technology, and we were discussing in those days with the US Air Force and Alcoa on, transferring that technology also to them, because at that time, Lockheed was considering to use the technology as an update for the C-130 Hercules.
Before they merged with Martin.
Yeah, when was it? I think somewhere 2008, something like that. Yeah, but we sort of were planning the meeting that we would come to the US to discuss that with them, and then at some point they sort of said, "Okay, we have to stop this. We cannot have this meeting because of the ITR restrictions." And we were sort of puzzled because it's like, okay, I understand ITR if you don't want to export technology out of a country, but we were still discussing to bring the technology to the US. But even that was apparently a problem, and that sort of was like, okay, that makes no sense to me. But for me, that was one of the illustrations that those regulations in the US were equally strict or even worse than in Europe.
And when it comes to developing those new technologies, you're balancing risk and reward. You know, what's your compass when it comes to risk, and what are some of the biggest risks that you've had to take?
At the academic level, I would say if you're not willing to take a major risk, then don't expect you will have a big contribution. So, it's a high risk, high gain. You should give it a try. On the other side, the risk there is that if you're too far ahead of everyone, people may not want to follow. So I had that in the past. I had that literally said to me by the head of technology from Boeing. I went there a few years, I think also somewhere 2008. I went to a Boeing Unitized Structures conference, and I gave there a presentation where I took a paper from a US university who did research with Boeing, but they were not telling which fiber they used. And it was some sort of a carbon fiber tech, but it had an aluminium foil on both sides. And, they reported results, but it was all normalized because it was all IP Boeing.
It wasn't very useful.
Well, I was looking at it and I thought, it looks to me like an FML. I have knowledge about how that behaves. So I did the analysis, and that's sort of reverse engineering. I could tell which fiber they must have used because I could then reproduce all the results. And that is what I presented there. And that was for them an eye-opener, like, okay, there's a lot of knowledge in the Netherlands. And then they came visiting us, and then the head of technology told me, and he said, you're clearly a decade ahead of everyone, but realize there's a risk. He said, if we don't see how far ahead you are or where this is going, we may not see the need for us to follow. So since then, I'm always trying to, indifferent of how far I will bring it, always have to reflect on how do I pitch it to industry, in where will it bring them, in what time window.
Do you think that, now that you say that if you're too far away, some people might not follow, do you think that does that mean that there's different tracks? Because with aviation, I guess that the biggest linear progress is, okay, from cloth planes to metal shells to propellers to jets. Do you think that it's going to be continue going on like that, or do you think that there's more varied paths to future?
There's certainly more varied paths. So, for example, initially people expected that we get from a metallic aircraft to a composite aircraft, and that was some sort of linear development. Yeah. And by now, you can hear industry talking about next aircraft may be metallic again. Simply because when the environment, the circumstances change, the economic change, and then you just make your decision based on different arguments. And for me, it is more of a landscape, a map where you're sort of moving back and forth. And what you will see is that the solutions being proposed or being applied, they may vary depending on the circumstances. For me, an eye-opener was, for example, that Mitsubishi Aerospace at the time, delivering for the Boeing 787, all composite, and then their own aircraft, they said, we do it metallic. And then it's like, okay, that's an interesting choice. That must mean that they know something about that technology, but for their aircraft, it turns out a different metrics.
Right. And now, this is something I've been thinking about, we were talking about earlier on. With AI, how do you think that changes the industry, especially for young professionals like us and people listening? How do you...
In aerospace, it may help to sort of recognize or identify the solutions we didn't think of. But what you see in aerospace, everything relates to safety. So whenever we introduce a new technology, we have to demonstrate equivalent level of safety. And there you can also see now EASA sort of calibrate on that and say, okay, how do we allow AI in this business? Because to some extent it's a black box. It's not always easy to explain why AI comes with a certain solution relative to something else. So they sort of aim for what they call an explainable AI concept, which in my view sort of stimulates us in whatever we want to apply AI or develop it, we have to sort of do it in a hybrid fashion to the extent that if we apply it, then we can still explain the outcome of what we do.
And do you think AI replaces aerospace engineers?
No, I don't think so.
No?
No.
Why not?
Because I think in the end, AI may do the 80% of the core of the work to be done, the 20% to finalize it. I see it as that is still human effort.
Yeah, especially for consumer expectations as well. You'd want a human to be certifying the engineering.
Because partly there's also perception in what we perceive as being preferred, or that changes along with societal changes, and the solutions AI comes up with, the way I see it, is based on regression of past data. So if you go towards the future, it may extrapolate in the right direction. It may also extrapolate slightly in a direction where everyone feels like, no, I don't want to go there.
Do you think that fear is cast more, or like the impact is more seen by like the individual person? Like, if it's this plane that I've seen in the media, I'm not going to buy a ticket. Or it's more professionals or regulators. Let's say that Boeing comes out with a new plane and Europe says, oh no, that's not safe enough. I don't get fly. Do you think it's more the personal side or like the big bureaucracy?
There's perception. I think the way we organize certification, it's, by definition, we have equivalent level of safety. So you never hear Boeing or Airbus say that the next aircraft is safer than the previous one, because at the moment you say that, you imply that the previous one was less safe. So they always go for an equivalent level of safety. But you can tell that certain choices are made or not made simply based on perception. And for me, the example is the window. So we have all those windows in an aircraft, which for me are only there because of the passenger. Because it's much safer to not have that window and just have an intact structure. First of all, much more efficient structurally because it becomes lighter, because you don't need all the reinforcements around the windows. But you can also give everyone a tablet or the screen in front of you where you say you can, with a camera, look outside. You see even more because you can look around, for example, and then remove the windows. It's much more safe, in particular when it's about, pool fires. Then, the fire comes in faster through the windows than through the fuselage itself. So there are reasons to say we should omit the windows, and we don't do that, mostly because of perception.
And so then what's the balance that you found between that theoretical approach and the real world applications of those theories?
For me, the theoretical approach are the means and the tools. In the end, what we deliver is something that society needs or wants.
Right.
And even though I can tell, I can provide you that it may be less efficient, if that is what they really express as we need that or we want that, and then you go for that.
Do you think that will change? Do you think that maybe, let's say that, I don't know, maybe not Boeing or Airbus, but a smaller airplane company, Embraer, comes out, Embraer is still pretty big, but they come out with a flush new plane, but no windows. And do you think that if airline says, oh, this plane is 20% cheaper, do you think that could encourage change? Or do you think that maybe not in our lifetime?
It could be. I think the price probably is what may, move people to make another choice. Other than that, they stick to a bias or an idea that they want to see outside what happens. And of course, from certification point of view, you need windows near the doors, because there you need to be able to see outside, is the fire on this side or not before I open the door. But for the rest of the cabin, you don't need those windows. But passengers may still perceive it as I want to see outside what happens. And that has to do with personal control. So you need to have the feeling that to some or great extent, you're still in control of the situation, even though you're not. And it's counterintuitive, but that is a psychological aspect to aviation,
like
where
round windows instead of square windows, or was it the other way around? Because the ships, they had the circular windows,
the potholes.
Yeah,
exactly. And then, in your day in the life, when you go day to day. Do you have these types of discussions with your colleagues? What does your typical day as a professor look like?
First of all, it's full with meetings at the moment. So I'm in a row. I'm having one meeting after another. Half of the meetings are, say, project meetings. The other meetings are meeting with individual students on their work, where we are mostly, discussing, philosophizing on how do we progress in this work. And near the coffee machine or over lunch, that is usually where we become a bit more philosophical. Sometimes you reflect more on the, why are we doing this? And
Is actually needed.
yeah.
And what percentage would you think would be okay? So majority of time is talking about it. Like, what percentage or what part of your time do you spend like at the aircraft hall, like stretching the new material, the composite, or like making sure that the structure is safe?
Initially, it was more than now. So I'm now in a position that I'm not doing tests myself anymore. So I come up with an idea. I give that, for example, as an assignment, a master thesis assignment. Students go into the lab, they will do the work, and they come back and say, "This is what I got."
Yeah.
And I usually say I learn by looking over their shoulders at what they do. Yes, I guide them, I give feedback and how to improve or what to do. But along the road, sometimes I send them with an idea into the lab and they come back and say, "You must be wrong because this is what I get." I said, yeah, okay, then I was wrong. But to me, that is how I learn as well.
Right.
So what I like about supervision of students in their work is I learn a lot from what they do. So the research I do is technically what they do, but where I fed them occasionally with ideas and with what they came back, that's what told me, this is how it looks like.
And so now that you're overseeing all these new developments in structures and materials, is there any specific technologies that really excite you? Like, oh, this is the future?
Well, what excites me is that there are a lot of promising technologies. If you look at additive manufacturing, for example, there's even a variety in how you can add material.
Right.
Whether you do, we are looking here these days at cold spray, but there are all these other processes with which you can do it. Some people refer to it as 3D printing. What for me the challenge is that where in the past we rolled a plate of aluminium, for example, and we know what we have. And now with the printing, because of the heat treatment that effectively the material locally has is different along the print. We don't know exactly what material we have at each location. So the challenges of understanding what we make become bigger. But to me, that is the fun. That is the puzzle again. Because can I sort of explain to people this is how it works, for example?
Do you think that well, as if Seb was saying, AI is going so quickly, we get basically a groundbreaking model every 2 or 3 months. Do you think that regulators will catch up to that? Maybe, we'll do a big analysis on 3D printed structures.
As long as we can explain the outcome.
Okay. Is it something that's led by them or by the scientists?
Now, what they do is they prescribe what an aircraft manufacturer has to demonstrate. So usually in the certification process, an aircraft manufacturer sits together with the authority like EASA, and they sort of negotiate, okay, based on the product we want to develop, which rules apply, and what would be the proper means to demonstrate compliance to these rules. And then for EASA, it's just a matter of wait and see what they come with. And then the aircraft manufacturer has to demonstrate, look, this is what we have done.
Right. And so now that you're kind of finding the contrast between what you worked on in the past and what's being worked on now, do you ever reflect on any projects that went on around you and think, oh, it would have been so cool to work on that?
I like my own project.
Yeah?
Yeah, it's
Fair enough.
well. The challenge for me is that the way we certified metallic structures is technically a very inefficient way. So it's if you wanted to know how the material behave, we do tests, and then you record the measurements, you draw the curve, and that curve is your model. But that means you can always predict something, but only after you have generated the data. And for me, the biggest challenge now is where the complexity of the material is increasing. Can we do that in a smarter way? to the extent that we can say, I don't need all these tests. I only need a limited, maybe static test or something like that, just to feed me with enough information to say, this is how it behaves.
And when projects of yours become very long or extended, how do you stay inspired or on the right track? And then what's your compass when it comes to this is it? Yeah, no more.
What does it to me is the intermediate report of findings so far, where someone on the other side of the table listened to it and he asked the question like, okay, but have you then thought about this, or this seems to conflict with something else? That's the new piece of puzzle. That usually triggers me.
And then when you're working with these younger students and they have moments like those where they're like, what am I supposed to do? What's usually your piece of advice when it comes to persevering through?
I'm sort of in my supervision style. I'm playing a little bit there with the student because I recognize sometimes that students themselves don't recognize they're onto something really of interest. So, for example, with one of the students recently started in his literature review, in one of the meetings, he sort of apologizes for not having spent time on reading papers in the few days before, because instead he took data from one paper, put the graphs in Python, started playing around, did some derivation, and he came with an equation. And I was looking at it like, that is cool. That's way more important than reviewing papers. So I said, no, don't apologize for not reviewing the papers. You did even more than that. But sometimes that reflection is what triggers people. So I had it, for example, once with a PhD student, came into my office, I think halfway in the 2 years. He got stuck. He was like panicking, like, I don't know how to continue. How do I do this? I was looking at him and I said, you're late. And he was like, late? We didn't have an appointment, right? I said, no, but usually people with this feeling come in 2 weeks earlier. And that was the moment that he started, you mean that everyone has this? Of course, everyone has that moment of, how do I continue?
Right.
And then you start talking, and that is sort of opening that perspective again. Okay, and then you start talking, and they walk out of your office, and they know how to continue. And that is so for me. The disappointments and failures, for me, is something you should embrace. I look at my kids. I can tell you, boys, they learn by failure. They try something, doesn't work. That is how you learn. It's even at that age a very effective way of learning. In science, we come with a hypothesis and we try to falsify. That is a negative feedback loop, but considered positive. Well, failure you can treat in a similar way. It's a negative feedback loop from which you learn. And if you consider that whatever you do, occasionally you will have failures, but those are the ones you learn from really, that will make you move.
And now, especially with your students, do you ever find yourself, or has there been any surprising things about your role and what you're expected to do? Like now that you're a professor, is there anything that surprised you about what you were expected to do?
I'm not sure whether it's that I'm surprised, but what I start to realize more and more is that the way I developed myself with the ideas I had and how I developed, I recognize now more and more that I'm supervising people that go through a similar phase. So occasionally, I'm sitting talking to a student and they put ideas at the table that I even didn't think of. And that made me realize that I'm no longer the person directing a student. I'm sort of facilitating, the circumstances in which someone can, develop and explore their own field, where I at most have to sort of reflect on, okay, what does it mean what you found? And did you think about everything, or are we missing out on something?
And is there any common misconceptions about the work you do? Maybe you're at conferences and people say something, you're like, no, that's not how it works.
On technology, there are so, for example, I had that discussion in those days when I was working on FMLs. You have metals and composites together in one system. They have a different coefficient of thermal expansion. So after cure, there's always a positive tensile stress in the aluminium, which is compensated by the compression in the composite. Which means that if you apply load, the stress in the aluminium is always higher than the load you apply, or the overall stress. And then I was talking with people from Boeing at that time, and they said, yeah, we can't apply glare, but why not? It's always initiates earlier than aluminium. But yeah, so what? Yeah, but if it initiates earlier, then we cannot use it. Said it makes no sense because yes, it initiates earlier, but afterwards it grows so slowly that by the time you can find it in an inspection, it's already taking more time to get to that point than in aluminium. So you have to don't look at initiation as a concept, but at when can I find it in an inspection. And that is one misperception on a specific technology. But on, say, my field of expertise on structures and materials in that sense, I can recognize that sometimes there's a misperception that we sort of ruin excellent ideas. You know, there are people in another discipline, for example, they come with a new aircraft configuration, aerodynamically they can prove it's much better. And then we come in and then we bring in all the problems. And it's sort of, yeah, we make their idea less efficient. And I don't know, aerospace has always been a compromise between disciplines. If you optimize it towards one direction, you then bring in the other departments, you will always have to reinvent yourself and come to a new compromise.
Yeah.
But for me, that is a misperception where in one discipline, you can find an optimum. Theoretically, you can, but for aerospace, that's never an optimum.
Do you think that there's like an old guard still in the industry? Well, I guess you would say 30 years ago or 25 years ago, Boeing was this wow super prestigious company. Well, it still is, not as much.
They have some problems these days.
Yeah.
Yeah.
And Airbus being basically this Frankenstein of all these aerospace companies around Europe. Do you think that that impacted a lot on the decision that, I guess, what would you call it, stubbornness?
I don't know. It's I think when you introduce new technology, even though you can prove this technology is better than a previous one, you have to realize that for an aircraft manufacturer, you're not only aiming for good in performance, but you also do the economics of what does it cost me to introduce this? What do I need to do? And at the end of the road, what is the gain financially for me to do it? So, and there I can see that companies are looking at each other. So take, for example, the single aisle. You know, our A320 with Airbus, 737 with Boeing. They both know that, you know, it's time for a new aircraft. And what you could see is that over a couple of years that those companies are looking at each other. And they sort of, if you don't do it yet, we don't do it either. Because then we just keep selling the aircraft we still have. Okay, and at some point they decided to come with an update, 737 MAX or a Neo, A320 Neo, for example, where they sort of, because they are the major players, they can look at each other and sort of, without spending a lot of words on it, decide a practice that they both can uphold.
Do you think that's the reason why now, well, you look at 50 years ago, there's so many different more aircraft manufacturers, McDonnell Douglas, Fokker, Dassault, even the Russian planes, like Ilyushin. And now there's only a few big aircraft companies. Do you think that these companies find like this unwritten or unspoken like fact and like rules are the reason why they're still alive?
That, and because economically it was not sustainable to have so many companies. So, for example, the fact that Fokker Aircraft went bankrupt, there were too many of these companies in the business. You know, it's not sustainable, because if you look at the cost of development programs of aircraft, over time, those figures are going up. Yeah, and it goes to the billions now. So you need enough momentum or financial backup to share a risk like that. You cannot do that as a small company. So I think those bigger companies, the way they do it, they can sort of reasonably address the risk, because in the end we have to face it, in aerospace the profits are marginal. You know, the investments is huge, but the margin, you know, economically it's relatively small.
And when it comes to working with all these different companies, what do you find to be the biggest distinction between, I mentioned it before at the start, the American companies and the European companies? Is there a difference in mentality, or can you not really tell that much?
I think the way I look at it, the US companies, they look more to their internal market. It's not only that Trump is now aiming for it, but they always did it that way. But also in terms of with whom do they work on development, I noticed, for example, that Boeing did spend effort on acquiring experience with fiber metal laminate technology, but not with working with us. They sort of do it, they try to find partners in the US to do it with, where in Europe, because essentially Airbus is a compilation of national industries, there's more of a mindset that whenever you go from France to Germany, for example, for a meeting, technically, okay, it's still called Airbus nowadays, but you can still tell it's a different company. So I usually use the example that I once went to Toulouse. I told the cab driver I need to go to Airbus, and he was looking at me, and then I showed him, this is the address, and he said, Airbus. I said, well, okay, so it's the French version of Airbus or the German version of Airbus.
And usually working with your students now, what advice do you give them when they work with industry partners? What do you want them to look out for?
Well, first, in their studies, realize that is the moment where you still have maximum freedom. So don't, for example, your master thesis, don't get stuck immediately into whatever an industry is doing. Take the liberty to, open the scope up and explore more options, because sometimes industry, they have a practice or a bias, and that is the way they go. And sometimes it's insightful to step out of that or go the opposite or even transfers to that direction and come up with another solution that essentially may be a better one. And so there you can be, sort of the person that has an impact. And you have to exploit it at least once before you get to industry where you sort of have to defend choices if you want to make those choices like that. And that is what you do best based on the experience of, for example, a thesis work.
Aero Delft, for example, they're going for a really, really ambitious goal. And especially you were talking about the mentality that, all right, 30 years ago, or since the faculty opened 80 years ago, okay, I will do my degree, I will go into Fokker, I'll get a good salary, I'll get a good life, have my kids, old. Do you think that difference now of students, let's make a hydrogen plane like they're doing, do you think that could bring maybe, I don't know, a new company that's completely student-born or a project like that, something not really seen before?
Well, it's there's always the challenge, and that I recognize when I talked with people from EASA, that those companies, as they say, we certify aircraft now for decades, but we do that with experienced, mature organization. They know how that practice looks like, and they sort of complain that with those new companies, they have to talk to a company that has no experience with certification. And then you get into that, then they have to teach the company first, this is how you do it. And then, so there's always a downside to a smaller company that if you want to introduce it, it takes sort of more time because you're not ready for the certification practice. The upside is that because you're smaller and less constrained in a big industrial practice, you can think more out of the box and try different solutions. The funny part is you mentioned Aero Delft. A few weeks ago, I had people from Airbus here, and then we went through the lab, and we walked up to Aero Delft, and they were coming from the development of hydrogen flight. Airbus up next. So there's a student explaining what they do from Aero Delft, and the Airbus people are watching that, and they look at each other and say, they're doing what we do on a different scale, but they're doing the same as we do. And then we went on, and they showed, the small setup of how that propulsion system looks like, and they were looking at it. They keep doing what we do. And they were sort of, they thought that was amazing. But at some point, the student felt, I have to apologize because he said, but we are not developing anything. We just take material and technology off the shelf and we put it together. And then one of the Airbus people responded with, we are an integrator. That's what we do too. But they were sort of amazed that students it's not even that the staff of a university, but students do this type of activity, realizing that it's essentially the same activity that a mature organization as Airbus is trying to pull off. And if you get to the point that, and then it's about inspiration, if you can inspire a company like that with what you can do, yeah, you almost pave the road towards sitting at the same table, and then let's discuss how do we continue with it.
In that case, do you think students have a big voice in what innovations are allowed into industry?
By demonstrating on the smaller scale, indeed, like this is how you do it, they can.
Do you think that it will lead to different branching off? Maybe we see a big new company, or do you think that this will be absorbed by, like, the big companies have way too much inertia for them to be toppled?
Yeah, but what you often see is that if the technology is relevant for the bigger market, like for commercial airplanes, it's almost impossible to, as a startup company, to get that share in the market, and then it becomes easier probably to relate to one of the bigger companies and to make it happen. If it's, for example, more the smaller the business jet, general aviation, that type of business, it is probably easier as a startup to sort of find your
Like a niche.
yeah, or at least slowly build up your share in the market. But I think initially students should not limit themselves on how does that work in the future. They first have to sort of challenge the technology to the extent that you can show, look, it also works this way, because that is usually the inspiration that this business needs.
Do you think there's also a misconception of students thinking, oh, like, since it's Airbus, it must be done differently, or at least your PhD candidates,
Yeah.
do you think they think they're doing something different?
Well, I think the misconception is that, and I see that even in lecturing, for example, in the master's, my course on fatigue of structures and materials, is if the initial perception a student may have is that they are overwhelmed by how much is done. With a big industry, how much that industry does. What can I do as a single individual in that business, or what can I do in this topic? And that is where you get sort of, impressed in the way of, okay, what can I do? Where I've learned that, and that is on purpose, where I started communicating the difference of opinion in that field. Because if you communicate, it is still a field in development. We're not there yet. That is much more attractive than to get the idea. Oh, wait a minute, I can contribute to that, or I can do that. And I think the misperception is that big industry, they have seen it all, they've done everything, they tried it, and if they don't do it now, they must have a reason why they don't do it anymore. That may be the misperception. Is if you realize that sometimes they just choose for something for completely entirely different reasons. If they have not done it, it may simply be because they never thought about it, or they thought as a bias that it won't work. If you can prove it will.
Is there any projects of yours, research papers, that have given you a great source of pride? Is there anything you look back on or are doing right now currently and you're like, wow, that was amazing?
Well, for me, what made me proud on the FML technology is, and that relates a bit to certification practice, where they always compare it with the pyramid, the test pyramid. So you get with the small coupons and the large element all the way to full scale. What you see these days is there are a lot of small tests, small coupon tests being done. And then they do element tests, and through models, they sort of try to bridge the layers in that pyramid. And what made me proud when I was developing the theory for how fatigue damage developed in fiber metal laminates, it became that generic that I even realized with the people I worked with at that time is if I apply stiffness, so I make it an element test, so I even start applying stiffening configurations, that in my method was essentially an additional term to the equation, it still worked. So with a single model, I was at the same time covering two layers in the pyramid. I didn't need a model to bridge one model to another one. that made me proud.
And then as well, you talked about your mentors and people who've really shaped you professionally. Is there any one or few pieces of advice that really kind of help guide you? Something you look back on?
Yes, do not focus only on the people that you like. So, for example, the professor about Vogelzang I mentioned before, he was, to me, he was a very inspiring person, and in that sense, it made me really choose and continue in the direction I went. But afterwards, as a staff member in this organization, I also started looking at other professors that were in the irritation zone that really annoyed me because the way they behave is something I dislike. But if you are open to it and you ask yourself the question, look, they do achieve a lot too. So what do they do that I can learn from? And then take a role model that is sort of out of your comfort zone and try to learn from that as well. That is where you learn the most.
Yeah, what defines success for you?
Well, for me, success relates to impact. So where you actually change a practice, where you sort of improve a practice. If you manage to do that, that is where you have impact.
Is it almost always in real life applications?
It can also be in that you change the mindset of people. So in my work, explaining with better physics, for example, the description how fatigue develops in a material, if that changes people on how they look at it and then continue doing research on this type of problem, it's impact too. So it doesn't need to be tangible, materializing ID through a structure or anything like that. But you at least need to be able to point out, look, here I changed a practice. For me, that is essentially key to success, because if you cannot show it, in academia, we, at least the way I grew up in it, initially there was a lot of emphasis on publications and look at the citations. Initially, your first couple of papers, you get cited, so you look up the paper and like, who's citing me? And then you read the paper and the first question is, why were they citing me? Because it sounds like they never read my paper.
Right.
And then you realize that, for example, citations, to me, it's not impact. It is, if I have a stupid idea and I put it in a paper and people say, look, that is something we should not do, I get a citation, but does that mean I have impact? Or even worse, if I stop doing research and I only write review papers, so I summarize work by others, those are the highest cited papers. But so for me, that is not impact. So the impact is really in where you change a practice, where you can show, look. So whenever I see an Airbus A380 fly, and you say, look, there's a material technology there that I contributed to that makes me proud.
Do you feel okay, let's do the example of the Airbus first flight. I guess you were really involved in that. Do you? Well, you've done the test a million times. Like nothing can go wrong. But I guess you would still have it like in the back of your head, like the doubt that, oh, what if the fuselage tears off, like the Hawaii, like the Aloha plane in Hawaii?
Yellow Airlines, yeah. No, not really. It's knowing what they allow as loads and stresses in the structure versus what I have been testing in the lab. There's for me such a safety margin that even if the crack occurs, I'm pretty certain it will stop after reaching a meter. So I was not worried at all. For me, it was more of a, okay, it works now. What's next? Can we further improve this?
Now that we're coming to the end of our time here, I just a few more questions. You mentioned one, being outside your comfort zone, and then two, embracing failure. Is there any other advice you might give young professionals and students that are looking for a career in aerospace?
If you're looking for a career in aerospace, try to recognize the mainstream directions or the potential bias people have, and dare to step out of that and try something else.
And then for the viewers and everyone watching, is there anything that you'd like to tell them, where they can find your work, anything interesting you might have coming up?
Well, I through my career, I started with fiber metal laminates, which was contributing to the material technology. with a better understanding and description of how it behaves. And at some point, it's like an S-curve. There's not much more I can do. It's now up to the industry. So I started looking at other aspects, and then I started looking at carbon fiber composites and trying to understand how fracture develops there, where I'm now also on a more academic side, try to better understand fatigue. So I really want to get to that point where I say all that fatigue testing, we can stop doing it. If I do this, I will tell you how it behaves in fatigue. So if people are looking for the what's next in my work, look for those papers.
And in general, I would say, let's say that a 15-year-old or something in high school finds our great first episode of our podcast. How do you think, what would you tell him?
Realize that if we really want to change in aviation, we get from a gradual development towards a disruptive development that automatically comes with a unknown, unexploited territory. So you step into something we don't know. And what you need there is people that sort of know how they can verify what they do and develop through that confidence this is the right way forward. And what you see now, with all that emphasis on clean aviation, flying electric, flying hydrogen, the business is trying to reinvent themselves because we are stepping now outside what we were used to. And we have to sort of start to learn from scratch again on what does our past skill and experience mean in going in this direction. So try to think of how can I, and I'll give you one example there. First year course, multiple choice exam. Years ago, I had another colleague from the space was then running the other half. In one of the cases, he failed to mention a value for one of the parameters, which was necessary in 2 successive questions. You get the sports center, panic all over because everyone is like, I cannot give this answer because I don't know. So at that point, you just say, skip it, we'll sort it out afterwards. But I'm walking around and I see a student who gave answers to both questions. So I pointed at it and said, how do you know this answer? And then he said, well, I know how to find the answer. So what I can do is use that method to recalculate the given answers back to that value. And I get 4 values. And he did that on the second question too. And then he had 2 sets of 4 values and there was only one in common. And he said, that must have been the value. And then I know the answer. Well, that is the skill that an engineer needs to develop.
Well, thank you so much for your time, Professor.
Thank you
It's
so
been
much.
great having you
Dr.
here.
You're welcome.
Alderliesten.
Thank you.
Hi, I am Elliot, the founder of Aerovia. Thank you for watching. Also thank you to everyone for the donations and to the Aerospace Innovation Hub. If you want more aerospace related content, go to aerovia.org. We would also greatly appreciate it if you can donate so we can produce more content for you. We'll also have aerospace merch coming soon.